welcome back to another stream. This is second to last stream. I'm pretty stoked to be doing this today. Sorry, so yeah, I was in a bit of a rush today as well, so I'm just setting up the stream again. So I'm gonna switch everything over to, I'm gonna switch from Firefox to Chrome just for the rest of the stream because I've been having trouble with Firefox, which is a bit unfortunate. I think I really want to use Firefox where I can, but with anything that's just JavaScript heavy, my computer seems to not be able to handle it, and it will either freeze or crash or both. And so I've decided to revert back to Chrome for now. See how that goes. I mean, it's just 2 days left, right? So we'll see what, yeah, we just have to do whatever. We'll just roll with it. So yeah, I literally just got home and I'm just sat down, set up my laptop and everything. So this is going to take just a little bit of time to set everything up. Get some proper spacing in here. Cool. Cool, seems to be working. And I set up with 2 minutes to spare, so that's perfect. Let's see. Let's recap yesterday's stream a little bit. Yeah, the cup thing. Hey, yesterday's puzzle was really good. And you know what it reminded me of? There's this mathematical puzzle. I think it's based on Josephus. Like, I think the character's name was called Josephus. And he had to, basically everyone stood in a circle. This was like they got defeated in a war or something, so they were it's a bit morbid actually. They we'll go with a different theme. So you just go around a circle and you start eliminating like every third person or something like that, right? And you go around the circle until no one's left. So let's say you start with 20 people. Where do you want to stand to make sure you're the person who's left? And I think there is a formula for doing that. Whereas for this one, I wonder if there's a formula for doing yesterday's challenge. But with yesterday's challenge, basically, yeah, you had a million cups in a circle, and you had to do the action 10 million times. And if you actually moved the cups around, right, with an array, copying stuff around and things like that, shifting things, that would probably take a lot of time, a lot of computing power, to just shift a million values around an array continuously. And so the solution was to optimize it is the same thing you would do with data structures. Just like how arrays are bad at moving things around, well, it turns out linked lists have constant insertion time, right? And so by structuring the array, by keeping track of the cups as, with pointers to the next one in a sort of linked list style type of thing, we managed to solve that really, really quickly. So I wonder what today's challenge is. Let's take a look. Lobby layout. So my raft makes a tropical island. Am I finally going to arrive at my holiday destination? Turns out the small crab we were playing games with him on the way. He helps us get to there. That's cool. As we enter the lobby, we notice a small problem. The floor is being renovated. You can't even reach the check-in desk until they finish installing the new tile floor. Oh, tiling. Oh, yeah. Okay, the tiles are hexagonal, even worse. They need to be arranged in a hex grid. Okay, so hex grids. There is a trick for hex grids. There is a website called Red Blob Gaming, and they have a really, really, really good resource for hexagonal grids, and it's amazing. This thing, it's like I might have to enable some JavaScript. No, should be good. Interactive things for different ways of laying out hex grids. This is my go-to resource for anything related resource for anything related to hexagonal stuff. Different coordinate systems, because obviously you can't use XY. My favorite is the XYZ system, but there are other ways to, so all the resources here, anything we might need to do, we can probably refer to that resource for how to do all the algorithms. So I'm just going to leave that up. Tiles are all white on one side, black on the other. They start with white facing up. The lobby is larger than the fit water pen might need to appear there. A member of the renovation crew gives you a list of the tiles that need to be flipped over. My puzzle input. Each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from the reference tile in the center of the room. Ah, okay. Because tiles are hexagonal, each tile has 6 neighbors. East, west. Okay, so that's the first thing, right? So this layout is, there are 2 different layouts. There's the flat layout and the pointy layout. Since we have east, west, and then I think diagonals, right? Yeah, southeast, southwest, northwest, northeast. We are in the pointy layout version, not the flat layout version. So that's something to keep note of. So these are east, southeast, southwest, west, northwest, northeast. Okay, so this is unambiguous because they all start with different letters. A tile is identified by a series of these directions with no delimiters. For example, ESENEE identifies east, southeast, northeast, east. That's fine. East and west, yeah, they all start with different letters, so you can always figure out what it is. Each time a tile is identified, it flips from white to black or from black to white. Tiles might need to be flipped more than once. For example, a line like ESEW flips the tile immediately adjacent to the reference tile. Right, yeah, so because it goes east, southeast, and then back west. So it's the same as southwest, right? I wonder if all east-west will always cancel each other. If you're moving in a line, does east and west always cancel? Maybe they do. Maybe they cancel. North, northwest, west, southwest, east, east, east. So does that mean, and a line like this flips the reference tile itself? Okay, I have to draw this backwards for the camera. So northwest, west, southwest, east, east. Is that the same as northwest, southwest, east? Yes, it is. Okay. In the above example, 10 tiles are flipped once to black, 5 more are flipped twice to black and back to white. After all of these instructions have been followed, a total of 10 tiles are black. Go through the renovation crew's list and see which tiles you need to flip. After all instructions have been flipped, how many tiles are left with black side up? That's okay. We can pick one of these coordinate systems and then just use that to identify tiles. Okay, I'm just gonna make this a little bit bigger on my screen just to see if they have more diagrams. Okay, they don't have more diagrams. That's a little bit upsetting. Now I gotta, there we go. Okay, so I guess we'll stick with the cube coordinates. That's okay. Cube coordinates have an interesting tautology. I think they always add to 0. Yeah, they always add to 0. Cool. But that should be fine. So there are ways you can simplify this list, but we're not going to do that because the rules are a little bit beyond what I'm comfortable with, like intuiting off the top of my head. So I will actually parse this input. Function parse, I don't know, identify tile, convert to cube, so line. Cool. So we just need to step through it, right? Cool. So let, actually, can you, yeah, okay. So let, I don't know what to call it, s equals line. While s.length is greater than 0, what we're going to do is we're going to just if we're gonna look at the first character. Switch S0, case E, then we look at this grid. X plus 1, y minus 1. Okay, so let x equals 0, y equals 0, z equals 0. If it's E, we go right 1. That means we go x plus equals 1, y minus equals 1, and we break. If we go west, then x minus equals 1, y plus equals 1, break. Case N. Oh, right. So we can't just break here. S equals s dot substring 1 to move to the next one. And we could loop over this. We could just use an index instead of substring. It's probably better if we used an index, to be honest. Oh well, I've started writing this. I'm going to commit. If S1 equals E, then do something else. We're going to just assume it's west. Break. Same with south. So if we go northeast, we go x plus equals 1. Oh, which one's northeast? This is northeast. Z minus equals 1. Break. Not break. Else, if we go northwest, y minus, oops, equals, no, y plus equals 1, z minus equals 1. Cool, and then s equals s dot substring 2. That's the same thing down here. Otherwise, if we go southeast, we go y minus equals 1. I'm just reading off the diagram. Z plus equals 1. And if we go southwest, then x minus equals 1, z plus equals 1. Return x, y, z, z. So we just look at the first one and see if it's right. We'll draw it up. Oh, let's do something shorter. They had some examples in here, right? ESEW. This is gonna, no, I shouldn't do that. I'm gonna mess myself up if I do that. If I change to that, my input. ESENEE should be oh no. Yeah, no, I shouldn't do that one. ESEW was the thing. ESEW should be, what did it say? Tile immediately adjacent to the reference tile. It should be 0, minus 1, plus 1. Yep. And this should be the reference tile itself. It should be 0, 0, 0. 0, 0, 0. Okay, I'm quite happy with that. It should be correct. I mean, everything in here looks unique, right? This one doesn't have any z's. This one doesn't have, this one is like minus z plus xy. This is plus z minus xy. So it looks good. So every tile starts off white. Yeah, so we basically just go for const I of input. XYZ is convert to cube I. We need a tiles equals thing. So if it's black, it'll be in it. If it's not black, it won't be in it. And we should end up with about 200 tiles. So const ID is going to be one of these things. It's inefficient, but it serves its purpose for us. If tiles ID is null, so it doesn't exist, tiles ID equals true, else tiles ID equals false. Actually, can I do this? So I can. If it doesn't exist, it's going to add it. Cool. Equals not tiles ID, and then I just find all the ones that are true, right? I'm just curious if there's any in here that are false. There should be ones in here that are false. Yes, there are ones in here that are false. Good. So we want all the ones that are true. So to get all the ones that are true, we can go object.entries, which gives us a key value, .filter key value, filter everything that is true, and we just want a length of that, right? 400 in my one, apparently. Black side up. It starts off, yeah. Yes, okay, 500. Hey pal, good to see you again. Yeah, it's an interesting problem. If you haven't seen my stream earlier, there's a really good resource. If you Google redblobgames.com, if you Google redblobgames hex grids, there is a wonderful resource with how to manage hex grids, and I've just been using that for my stream. If you want to attempt it yourself, yeah, give that a go and see what you think. So part 2, the tile floor is meant to be a living art exhibition. Every day tiles are all flipped according to rules. This is like another Conway's Game of Life thing. Any black tile with 0 or more 2 black tiles immediately adjacent to it is flipped white. Any white tile with exactly 2 is flipped black. Here, tiles immediately adjacent means 6 tiles directly touching the tile in question. Yep. So it's a Conway's Game of Life kind of thing. The rules apply simultaneously to every tile, right? So they just don't. You apply it. You work out whether tiles should be flipped first, and then you flip all the tiles at the same time. In the above example, the number of black tiles that are facing up after each day is as follows. Right, so these are the ones that start off flipped, right? Okay, so let's do that. We can still probably reuse most of this code. Const test equals, so this is the example. So we'll call this, so tiles for each tile of test. And make sure I'm not going to make the same mistake I made yesterday. Test is the only case where we need to use test. Okay. So tiles. Cool. In fact, we could have just used all of that code. Oh well. So 10. After first day, there are 10 tiles flipped. Okay, no, 10 tiles at day 0. So this is day 0. Is 10. So we're going to do a function step. I'm going to give it some, I'm going to call it map just to not mess up my variable names. It's the same as before, eh? Yeah, this is exactly the same as the Conway's Game of Life thing we made before. Okay, so let's do this first. We'll check all the tiles that are currently flipped first, is what we'll start with. All the black tiles with 0 or more okay. So we're going to get all the black tiles. We're doing a lot of extra parsing in this one again. All the black tiles. K.split on comma.map number. I think. So we're going to have const black equals those are all the tiles that are black on the first day. So any black tile with 0 or more than 2, with 0 or more than 2 are flipped white. Okay, how do we get all the adjacent tiles? Turn. There's 6 adjacent tiles, right? And according to this, the adjacent tiles are you plus minus each of the numbers around it. So we return x plus 1, y minus 1, z, x plus 1, y, z minus 1. Then you have x minus 1, y plus 1, z, x minus 1, y, z plus 1, and you have x, y minus 1, z plus 1, and you have x, y plus 1, z minus 1. I believe, or the adjacent tiles. Okay, so for const t of black tiles, for const adjacent of all adjacent t, let's count equals 0. If black if map I was gonna check like the tiles directly, but I'm just gonna check the I'll just do this thing. Actually, how many days do we need to check? 100 days. Okay, we'll try and make it a bit more efficient. If black dot sum x is adjacent 0 and y is adjacent 1 and z is adjacent 2, then count plus plus. That'll be more efficient than thing. So because we have all the black tiles in here already, so we'll just take all the black tiles, just check if count the number of black tiles next to this tile, right? If count is 0 or count is more than 2, it is flipped to white. Okay, it is flipped to white. Otherwise, it remains as black. Okay, you know what? We're going to go const out. We're going to write it to a new one. write it, so out so we need this anyway, huh? Equals true, equals, it is flipped to, if it is that, it is flipped to white, it is false, else it is black, which means it is true. If it's white, it just means it doesn't exist in the array, right? We don't actually have to write it. Greater than or equal to 1, if it equals 1 or it equals 2, which is the other way of saying that, then we write it to out. Cool. So that takes care of all the black tile rule. But the white tile with exactly 2 black tiles is flipped to black. So we need some way of keeping track of of all the adjacent tiles, a number of tiles adjacent to. Okay. So the one way to do this is we're going to have another array, tile count. And in here, for each adjacent tile, every adjacent tile, we will just go, let's put this. Oh, this is, it shouldn't be adjacent tiles. Oh, that's almost wrong. It's not the adjacent tile. This should be T. It's the black tile. Becomes true. Stays true in the next thing. But here, every adjacent tile, right? Every adjacent tile needs. So every time we find a black tile, we're gonna look at the 6 tiles adjacent to it and increase a count on them by 1. That way we can then just go through that list to find all the white tiles that have exactly 2 black tiles immediately adjacent to it. Yeah. So we go tile count this. Okay, so we actually need to do another save in the variable. It's this. If tile count ID doesn't exist, then it becomes 1. Else, we increase it. Cool. So now for const key value of objects.entries tile count. So now we go through all the tile count tiles. If it is a white tile, so if the count is exactly 2 and the tile is a white tile. Now how do we know if it's a white tile? If it is false in map. Yeah, and it is false in map. And not in map, then it needs to become black as well. Return out. It's okay. Objects.entries. Because I can't type. It should be object.entries. Cool. So day 2. So we're at day 2 now. Day 1. Day 1 should be we didn't need to do this, eh? In fact, it should just be the same. 15. And that should just be the same as entry.keys that .length. Yeah. because we don't write false into the array in our step function. We only write trues into our step function. Day 2 should be 12 though, because we need to put in this. Ooh, made a mistake somewhere? That's not good. This algorithm is so black box that I don't know where to start. The first thing I thought of actually is here. Where's tiles? Here. We can actually do a we can get rid of all the false entries. Well, it doesn't matter. Maybe this is wrong, but I don't think so. I have 2 x pluses, 2 x minuses, 2 x's. I have 2 y's, 2 y pluses, 2 y minuses, and I have 2 x pluses, 2 z pluses, 2 z minuses, 2 z's. So that should be okay. Every black tile with a tile that is black. We increase the count. Oh, well, the only way to do this is to draw it out, but I'm not going to draw it out on my computer because I can't. It's too hard. So I will have to find a piece of paper and draw this out by hand and see where I've gone wrong with my algorithm. Ah, they're arrays. Oh, no, dot keys, right. I was like, wait a second. Huh, maybe I can find like a hex grid that I can draw online. Yeah, let's just do this. You know what? Let's use this one. Oops. Let's use this one. Because this one probably does everything we want it to do. I just need to take a screenshot of it so I can do something with it. Okay, I don't know how to do that properly. Okay, so let me see if I can get that up on my stream. Here we go. Cool. Just gonna make that a little bigger, fit it a little nicer on my screen. There we go. So I'm gonna need some markings, huh? This isn't very drawing friendly, but let's see what happens. -3 1, 2. Great, I have invisible lines. -3, 1, 2. -3, 0, 3. -2, 2, 0. 0, 1, -1. 1, -1. Oh, actually, I did that wrong. No, I did this wrong. I just realized I can't see my chat. X, Y, Z. Okay, X, Y, Z. Okay. -3, 1, 2. So this one is my first one. -3, 0 plus 3 is my second one. -2, 2, 0 is my third one. 0, 1, -1. 0, 1, -1 is my fourth one. -2, 1, 1. 3, 0, -3. 0, -2, 2. 0, 0, 0. 2, -0. Oh wait, 2, -2, 0. And -1, 2, -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe that is wrong. I should check that. There's my test input. Oh, I can't be bothered parsing that though. I'm just gonna assume it's right. If I don't end up with day 1, then I will know something is wrong, basically. What's the best way to do this? Okay, let's get another screen up. Set this up on my stream as well. There we go. Okay, now we do this by hand and see what we get. So this guy stays on, I think, based on the rules. So the rules were if it's black, it has to have exactly 1 or 2 neighbors to stay black, I believe was the rule. Yeah, if it's black, if it stays black if it's got 1 or 2 adjacent neighbors. Otherwise it becomes white. Okay, so it has 0 neighbors, so it becomes white. Any white tile with exactly 2 tiles next to it is black. Okay. Gotta find my windows again. Sorry, there we go. Okay, so this one's gone. Actually, I'll just keep it. This one's gone. This one's gone. And it's just this bunch here. These black tiles all have exactly 1 or 2 neighbors, so they all stay, I believe. So they all stay. Now we look for all the white tiles with exactly 2 black neighbors. So the way I did this was I basically counted, I counted all the tiles around them, right? So this is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 2. This guy's 2. Wait, 1, 1, 1, 1, 2, 2. 1, 1, 1, 1, 2. Then around this guy, we've got these 3 left, so this is 2. This is 2. Around this guy, this is 2. This is 1. Around this guy, we're only checking these outside ones. Eh? That's 1, that's 2. Around this guy, that's none of these are 2. This is 2, we've already done that. Around this guy, that's not 2. That is 2, we've done it. That's not 2, that's not 2. Around this guy, that's not 2. That's 1, that's 2. It's 1, 1, 1, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let me move that screenshot over to there and get my tmux back. We should have 0, 0, 0. Yes, we have 1, minus 2, 1. Yes. Let's go from top. We have 0, plus 2, minus 2. 0, plus 1. Yes, I see it. Minus 2, 3, 1. I see it. Minus 2, 3, minus 1. Yeah. Minus 1, 2, minus 1. I see it. 0, 1, minus 1. I see it. 1, 0, minus 1. I see it. Minus 2, 2, 0. I see it. 0, 0, 0. 1, minus 1, 0. I see it. Minus 2, 1, 1. I see it. You know what? I think I know where I might have gone wrong. Because I don't see anything wrong with that algorithm. Am I referring to? Yes. I knew it. I knew it. This is, oh, why do I keep messing myself up with like global variables, man? That's the second time in 2 days or in 3 days I've done this to myself by using global variables and capturing them into functions. I am so sad. Like, literally. Let me get my challenge problem back up on the screen. It's there. 25, that seems right. Okay, so let's automate this. Let floor, I'm coming up with new names. And I'm gonna, like, I even specifically like remembered to check earlier to make sure I'm not gonna run into this problem, and I still ran into this problem. Less than 100? No, I equals 1, I less than equal to 100. Day I object.entry object.keys floor dot length. We'll start from 0 actually. Floor equals step floor. Ooh. Just be tiles. Oh, we're slowing down. But that's okay. It's okay that we slow down. We have 15 on day 1, 12 on day 2, 25, 14, 23, 28, 41, 37, 49, 37. Day 20 we have 132. Day 30 we have 259. Day 40 we have 406. Day 50, 566. Day 70, 1106. Yeah, so I'm not going to optimize it. I'm just going to let it run. But I will do it this way around, so we don't do an extra bit of work. 80 is 13. Yeah, I'm happy with that. Cool. Let's do it with input. See what we get. Oh, it's going to take even longer though, because input is so much bigger. That is really suspicious, and I'm really scared. But since we have an answer, oh man, that's so gonna be wrong. Did I mess up a variable again? Yes, and it's not input that goes in here, right? It is always gonna be tiles. This one I'm not gonna mess up though. I'm doing a lot of string, like parsing strings and creating strings and stuff. This is where I really want like structural equality with like structs and stuff. And I don't think JavaScript provides that out of the box. You would need a helper function to manually check every field or whatever, right? I'm happy to wait. Like, it's not that much longer. It's only, if it's like a minute, it's okay. Okay, so this was basically, but like in summary, right? This was basically just Conway's Game of Life, but instead of, if you don't know what I mean when I say Conway's Game of Life, there's probably a really nice Wikipedia article about it. There's some really crazy stuff that you can do. People have built, so using a system like this, people have built computers, like general purpose computers. There's a write-up somewhere on the internet about how they built a general, so someone posted on one of the Stack Exchange forums a bounty for someone to make Tetris in Conway's Game of Life. And so the team of people who eventually did that, what they did was they, instead of building Tetris in Conway's Game of Life, they built a general purpose computer in Conway's Game of Life, which then they built Tetris on top of. And like it takes millions or billions, like so many time steps to execute one step of Tetris. But apparently eventually it gets there, and you can do some pretty amazing things. But it's all based on the simple idea of two basic rules. So basically two basic rules. And it's you can read the more detailed rules on the Wikipedia article, but it basically boils down to what we had here, right? Any tile that is on stays on if it's got a certain amount of on tiles around it. Otherwise, it becomes off. And every off tile that has a certain number of on tiles around that becomes on. So I have an answer in my thing now. I didn't realize I was talking so much. I got it. Yes. Okay. So that means it doesn't say what we got. So we got way past 1,000, but that's okay. Let's see. Yeah, because I spent so long trying to debug it when it was again just a bad just a copy pasted variable name that was wrong. This is why putting things in functions or in modules or making private variables or whatever is so important. So you don't accidentally reference the wrong thing. Yeah, so maybe I'll just look this up real quick. Conway's Game of Life Tetris. CodeGolf.stackexchange. Yeah. Yep. So it was on the CodeGolf version, but yeah. So some guy's like, "Hey, can someone build Tetris?" And then these guys did it, and there's like this giant write-up of like all the different parts and how they linked all the different components together. You have like metapixels which can become on and off over a period of 35,000 time steps to either fully turn on or fully turn off. They built logic gates apparently, delay components, demuxes, implementing like logical operations, latches, which they then built after they have stuff, and then they end up like it's crazy. I haven't actually fully read this. I just know that this exists. But yeah, based on these simple rules, they did that. So yeah, Honeycomb, Hex Grid, Comic Game of Life. Pretty cool. Just let me read my chat real quick. Thanks, pal, for the congratulations. This just makes me think about bees and yeah. Bees do some pretty crazy stuff too. How they coordinate things, and I think hexagons are like geometrically quite a good structure as well. To build sturdy things, and that's why honeycombs are hexagons or something like that. But anyway, that's it. Again, it's been another 50-minute stream, so I'm just gonna head off now. Thanks for joining me. Tomorrow's the last one, Christmas Day. If you will, I know Christmas Day, it feels a bit weird to like do a stream on Christmas Day at 6 o'clock as well at my local time, but I'll try to do it. Hopefully it won't be too long, so I won't be too away from my family for too long. But yeah, so thanks for joining me, and I'll see you again tomorrow. Hopefully